Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Hopefully, you guys are doing well. Had a long night, but let's get through this. I anticipate today's lecture being short. We'll see how that goes. You guys know me. Sometimes I go off on a rant and just start blabbering about stuff. But for the most part, we're going to finish chapter 3 today. That's for sure. We just have 2 more examples to do, which I think I left in the notes for you guys to try. Going to do a quick summary, and then that ends chapter 3. And I want to actually also, I don't want to start chapter 5. I don't think that's, but the next thing we're going to do is chapter 5, but I don't want to start it. But at the same time, I think I'll do a couple examples of some prereq stuff to chapter 5, just to kind of jog your memory about some stuff. But also that I'm going to do very quickly because I'm not teaching you any of that stuff. It's stuff that I kind of already expect you to know. So overall, things should be, we should wrap up relatively quickly. We shall see. Okay. So this is where we were. We talked about sinking funds. That was the formula that applied to future values of annuities. And then we started present value of annuities. And so we ended up with this formula being the main formula of last class. And so it's talking about, okay, if you have some present value now, what are the payments to kind of pay down that in debt if you are being charged this interest rate, right? So this is called the amortization formula when you actually solve for that payment. It has a couple of nice examples. Usually this is the formula that's used against you by lenders, people lending you money that are going to use this to know how much your monthly bill should be, but you can also use this as a consumer. So we have 2 examples to wrap up where we were using both of these applications. So that is where we are. So present value of annuities, examples from last time. Hopefully you tried them. Let's go. Let's go. Okay. Goo. Okay. Okay. So a loan firm, they're willing to lend you $100,000. You want to open a new business. You want to borrow $100,000 for your startup capital, because you never heard of GoFundMe or anything like that. So you go to these people. They say, all right, I'll lend you $100,000. I'll charge you 3.99% APR compounded monthly. What would your payments be if you had to make fixed monthly payments over a 5-year loan term? That is the question. Okay, so you have a present value of $100,000. I give you $100,000 right now in the present. What do your payments need to be to kill that debt? Right, that's where the amortization, the word amortization comes from. Amort, to kill, debt. All right, cool. So we saw last time that we solved for the formula in the present value form. It was PMT. It was 1 minus 1 plus R over N to the minus NT over R over N, which we could solve for because they want us to find what would your payments be, right? So we want PMT. So, I'm going to take that formula. I know that's the formula that deals with me paying down a debt. So I'm going to use that and I'm going to solve for PMT. So that's the private value. Present value times R over N over 1 minus 1 plus R over N minus NT. And here we know our present value. That's 100,000 that we're getting right now. Our interest rate is 0.0399. It's compounded monthly. Yes, compounded monthly. We have a term of 5 years. And that's all the numbers. So what we do now is we jump in and we try to figure out what our monthly payments are going to be. So we have here 100,000 times 3.99% interest rate compounded 12 times per year. So 3.99% interest rate 12 times per year for 5 years. So that's going to be our formula. You just plug that in. And what do we get? What do you mean, can I use compound? You mean the compound interest formula? Is that what you're referring to? Well, no. One way we can know we can't use the compound interest formula. So the compound interest formula is the one that says basically A is equal to P 1 plus R over N to the NT, right? Which if you're solving for present value, you might think that, oh, I can solve for the P and do this, right? So let's say you have this formula. The immediate thing that should tell you that that's the wrong one to look at is there's no PMT in that formula, which is the thing you're searching for, right? So yeah, that formula definitely doesn't have what we want. And also that formula that I gave you is actually for a one-time lump sum payment. Here, obviously, you're making monthly payments. You're making repeated payments. So the original compound interest formula that I gave you guys is for like a one-time thing, right? You pay one time and you forget it, right? So there are a couple of things like that. But I get it. That's why I'm going to give you guys a summary today, because I do understand we had a bunch of formulas so far, and sometimes it can be confusing as to know which one to use when. So I will actually cover that in more detail later. What do we get?
1,841.20.
Yeah, that's what it's going to cost you to borrow 100,000 in this example. Borrowing 100,000 at 3.99%. I don't think that's very realistic, actually. 9% maybe, if you're like a big shot, great credit score, you have a fair amount of money. But
I got 331.68.
okay, so something is probably wrong there, because I got this value that this person said. So we'll go with the consensus, what most people got. So I also got this value when I worked it out. So double check your calculations, all your parentheses, all that stuff. Yeah, but for an average person, let's say you go to like a lender, maybe it's going to be 16, 19%. You can go fancy and try to open a line of credit for 100,000 and then get charged like almost like a credit card for 9 or 10% if you have a good credit score. But yeah, if you're being charged 3.99%, that would be your monthly payment. That's what it's going to cost you to borrow 100,000. The second one.
Wait, what if you set up the payment for like 20 years? There's no way it would still be like 16%, right? It'd be like way lower. Does that make sense?
Right. But the thing is, most people won't give you that long. Right. Like
Okay.
loan terms are also like, you can't just be like, can I pay you back in 100 years? Like, it's not, you don't have the choice. Like usually they're like, the interest rate drops if you have a longer loan term. So that you'll have a standard set of terms you can do. You can say, we can give you a 3-year loan or a 5-year loan or a 10-year loan or something like that. Unless it's a mortgage or something huge like that, you're not going to get like 30 years to pay something off. It's very rare to have that.
Okay.
Yeah, you go for like a personal loan or like a business loan or something like that. They tend to want their money a lot sooner.
Yeah, that makes sense.
Yeah. But yeah, you're right. If you have a long loan term, they'll usually charge you a lower interest rate. Like for houses now, like what, 2.5, 3%, 4%. But that's because they have 40 years to drain that money out of you, and compound interest, it adds up for them. But yeah, loans like this will usually be short term. You're not going to get a business loan for 100,000. Like, yeah, pay us back whenever, 50 years from now, it's cool. Like, no, it's not going to happen. So yeah, here's another one. So here's how you can use the formula for you. So again, it's kind of in a way where you're thinking about it to pay down debt, but you're more thinking about it from the standpoint of you figuring out what debt you can afford or what payments you can make so that you know what to negotiate for. So this is like the max purchase price problem, right? So you might see this phrase in your homework or whatever that talks about max purchase price. And whenever you see that, that's actually a signal that you should be using the amortization formula. So you want to buy a car, right? So you budgeted, you figured out how your money's working, because I got a checking and a savings, and sometimes to move never mind. Okay, so do you guys even know where that's from? You guys need to catch up. Okay, so you realize I can afford $450 a month comfortably, right? So you did your expenses, you accounted for rent, food, whatever. You're like, you know what? I can take an extra $450 out of my monthly spending and devote that to a new car. I want a new car. I need a new car, right? So that's what you decide. You go to this dealership. They say, okay, we're offering 5-year car loans at 2.99%, special price, no credit check. You don't need to prove that you have all the money. You just show me you have a job, show me a pay stub, and we're good to go. Those are no credit checks. So you're like, all right, I'd rather get a simple interest loan, but my credit is like not great. So I guess I have to do this, which is why building your credit is important in America, kids. So now you're going to take this deal pretty much, right? So this is what you're going to do. So if you want to take advantage of the deal, now the question is, if you actually go into the car dealership, what do you negotiate for? $50,000 car or $20,000 car, $35,000 car? Like, how nice of a car can you get? Or at least, what price do you need to try to get your dream car down to be, right? This is called the max purchase price. This is the maximum price that you can afford with the payment you have already determined that you can make, right? So you go into here and you know your payments, right? So here, we know the PMT, right? That's the PMT. Right? What I want now is what's the present value? What is the current amount that I can borrow right now if I know what payments I can afford? Okay, under this scenario, right? So it's kind of the same thing. So here, what we know is we know the payments we can afford, which is $450. We know the interest rate is 2.99%. We know the loan term is compounded monthly. So we know it's compounded monthly over a 5-year term again. And so what we can do is you can say, okay, if I know the payment, then the present value, the amount I can borrow now, will be the payment 1 minus 1 plus R over N. The minus NT, don't forget the minus. That's a very common thing to do when you're plugging into a calculator, over R over N. And we just plug it in. So it's going to be 450. 2.99%, 2.99% interest rate over 12 months. We're doing that for 5 years. And again, 2.99% over 12 months. And then that's the level of car you can afford.
I got $25,049.75. Maybe, maybe not.
I got 76. What was your third decimal place?
A 5. You're right.
Yeah, so all right, so I'm in agreement. $25,049. So you kind of know where you're hitting, right? So don't go in and ask for a $50,000 car. It's not going to happen, right? Try to bargain your way down. It's not going to happen. But if your dream car is 27,000, you know you're going to go in there and be like, yo, my dude, hook me up. Come on. Give me the car for 20,000 and I'll sign right now. You're like, can't do 20,000, man. This car is at least 27,000. And you're like, 22,000, my dude. And you're like, nah, man, maybe I can drop down to 26 for you. Like, yo, I'm trying to help you out. Don't you have a quota at the end of the month? You know, it's like it's like January 29th, you know, New Year's coming in, you have quotas to meet. 23. And he's like, give me for 24.5. Deal, right? Because you know in your head what you're trying to get. So you lowball them so that they come down, but then you're like, okay, you're kind of like, nigga, that's a whole other class. They should have like a negotiation class, right? But you know what you can do right now. You understand? You know that if you have to pay more than 25,000, you're in trouble, right? But yeah, that's how you'd figure that out. That's the max purchase price. That being said, be careful when you're buying a car, because depending on the state you're in, there are all these extra fees. Like you'll decide that you guys are buying a car for 25,000, but then after they do all the paperwork, they add a document fee and this fee and this kind of registration fee and this kind of fee, and it ends up being $2,000 more expensive than you thought it was, especially in Jersey. In New York, they don't really do that. In New York, the extra fees are like a few hundred, but in Jersey, it's like 1,000. So normally when I negotiate for a car, I negotiate for the out the door fee price, right? So that's kind of the price. That's like me indicating to them, I want the price that after you add in all your fees, that's what I'm paying. So don't mess with me. I know what I'm looking for, right? You gotta be savvy or these people take advantage of you. Okay, so those are the two examples. That's kind of it. That's all we need for chapter 3. Yay! But to actually go back to a question I was asked in the chat earlier, where it was like we were unsure of what formula we should be using, I figured it would be nice to do like a summary here. Okay, so there are two main scenarios that you want to determine that you're looking on based on the word problem that's going to give you, right? So in this section, it's usually going to be like, there's a word problem. You're going to read some sentence about some scenario, and you're going to have to figure out, I need to use this formula, plug in these calculations to find the answer, right? So how do you know what to do? So you need to identify certain things. So there are two main types of situations to look out for. There is the one-time lump sum scenario and the multiple payment scenario. Right. These aren't like any official scenarios, but I'm just talking about in terms of what this class will kind of test you on. So there's going to be a couple of things. So if you read a word problem and you realize, I'm just putting in a bunch of money and then forgetting about it for 20 years and then coming back to see how much I have, that's a one-time lump sum scenario, right? Versus if something is like, oh, you have to pay $1,000 every month repeatedly for over 5 years, that's a multiple payment scenario. So that's the first thing you want to figure out. Is this a one-time lump sum kind of deal? Or is this something that where it's like multiple things over a long period of time, right? So that's the main thing. So once you determine it's a one-time lump sum scenario, that leads you to the formulas that we did in the beginning of this class. That's going back to 3.1, 3.2, right? So the one-time lump sum formulas, which ones did we cover? Well, simple interest. Right, so that's where your amount was equal to P times 1 plus RT. It's linear, doesn't grow very fast. Compound interest. So that's A equals P times 1 plus R over N to the NT. Related to compound interest, there was the present value of lumps. I don't know, there's not really a nice thing to just call it, of a compounded lump sum in future. So that was just me, it's me rewriting the compound interest formula, right? But you kind of think of it in this way. Minus NT. So that's like, how much do I have to deposit now in order to have something compound up to this value at some point in the future? But again, I'm making a one-time payment. I'm not repeatedly paying anything. How much do I just put in now to get this to happen, right? Of course, there's the compounded continuously. And that's the A equals PE to the RT formula. Okay. And these situations, they are going to be described, right? So if there's an interest situation, it has to be mentioned that it's simple interest, or I have to tell you, oh, it's compounded this times per year, or this many times every month, or whatever. Like that has to be given to you in the problem. Same way, compounded continuously will be given in the problem. The problem's going to say, blah, 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 compounded continuously, blah, 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 right? Once you determine that it's a one-time lump sum scenario, it means these are the formulas you should be thinking about. Now let's go to the multiple payments scenario. Which ones did we cover? We covered the future value of annuities formula. Which is FV equals PMT times 1 plus R over N to the NT minus 1 over R over N. This is equivalent to the sinking fund formula. Which is just the formula when we solve for the payment instead. So it's FV times R over N over 1 plus R over N to the NT minus 1. We also looked at the present value of annuities formula, which is what we were just talking about. And that is PV equals PMT 1 minus 1 plus R over N to the minus NT over R over N. This is, of course, equivalent to something that we call the amortization formula. Which is what we get when we solve for the payment part. PV times R over N over 1 minus 1 plus R over N. Okay. But now those guys also have their own kind of scenario when you want to use them. So when to use the above. So use sinking fund, which again is the same form as the future value of annuities. Use sinking fund when you are saving up to a goal, making payments to save up to a goal. Okay. When else would you use it? Or you want to figure out payments now to have some lump sum to meet a future obligation. Right? So I want to save for my kid's college fund, right? 18 years from now, I want to have enough money to send my kid to college. Or I want to get a house, but I don't even have enough for a down payment. But I know the down payment is this. So what I'm going to do is I want to save up to the down payment and then go get a mortgage, right? That would be a sinking fund formula, right? You're saving up to something. There's a specific goal in mind, or you just want to know what a lump sum in the future will come from some payments. What future value will you have at time t if you invest? And I want you to think invest. It's your money's growing for your benefit, so it's not like it's going to someone else. If you invest your payments starting now until time t. Right? So these are all situations in which you'd use the sinking fund formula. So you're going to read the problem. If you realize, oh, it's about repeated payments and it's about me saving up to something, this is the formula you use. You're going to use the formula right here. You're going to use the sinking fund formula. Of course, there are times to use the amortization formula. If one, you want to pay down a debt. You're borrowing money now. But will pay it off via regular payments for a fixed amount of time. You could also do it to figure out max purchase price. So that is, you know your payments, what debt can you afford? Right? Yeah. You can also do it if you want to. I think that's all the scenarios we kind of covered, or I can anticipate us covering. So those are kind of the situations where you would use those, right? So figure out if it's like a one-time thing, then you use all the formulas from the earlier section. Once it's a multiple payments thing, then you're going to use these fancy formulas, right? These are the big boys for like the more complicated situation. And you use each of these in very specific scenarios, right? So one is all about saving up to a goal. The other one is all about paying down some debt, right? So you have the lump sum and you want to figure out the payments that can whittle down that lump sum versus what payments you have to pay to get up to some lump sum in the future, right? So that's kind of when you would use the scenarios. For larger projects, I wouldn't ask you a question where you have to do both of these for the same thing, but it might be useful for your project later on in the semester for larger projects. You can mix and match. So I gave a more morbid example last time where it's like, example, you now at 20 or 18 or whatever, you know you're going to have a working life. You retire at 60, then you know you're going to live for a certain amount of time, and you're like, you die at 90, right? Expected. Right? So now it's like, but you want, so this is here your working life where you can work, make money, save, invest, which after this class, everyone should be investing. I don't know how you can go through a class like this and be like, oh, I never learned anything in school. If you didn't learn to invest your money, that's, dude. Okay, so one of my friends asked me the other day, you invest in the stock market and stuff? I'm like, I'm a math teacher. You realize that, right? You know I know what compound interest is, right? Like, what do you mean if I invest? like, I'm offended by your question, sir. You know, some people are like, I don't want to invest. The stock market goes down in recessions and I'm so afraid. Like, no, like investing, there's a risk that you're going to end up in trouble in the future. Not investing, it's certain, right? And there are ways to mitigate risk, certain types of investments that are less risky. Yeah, sure. If you're getting closer to retirement, you don't want most of your money in the stock market. You start to funnel it out to something more safe. Yes, right? There's a way to do it. But don't just be like, let fear not let you do something. Use the knowledge that you're learning to know this is the right decision. I should be risking my money in investments. Like, it's like, yeah. It's like one of those, you miss 100% of the shots you don't take kind of thing. Okay, so here's your retirement. So let's say you want certain payments in retirement. To last about 30 years, then that's an amortization problem, right? You can just think of the amount of money you've saved by the time you're 60 is like a loan you're giving yourself. And you are going to make payments to this loan, which really means you're going to be withdrawing money to spend on your life expenses. And you want that loan to run down when you're 90, not before. If it runs out a little after, it's fine, but you don't want it to run out before. That's an amortization problem, right? That's what you're going to figure out. Also, amortization is going to tell you, if I know my payments, this is like knowing the price that you want to pay per month for the car. You just want to know, what can I afford, in the sense that, what do I need to make sure I save up to in retirement, right? So that's an amortization formula. This is going to be the PV, is what you're going to use for this part of your life. What present value do I need to be able to live in retirement, not working, and be able to withdraw $3,000 a month? PMT is 3,000 for you. How much money do you need to have in the bank to be able to have that for 30 years? T equals 30, right? You'll be able to talk about your interest rates and what you can get, right? So yeah, planning for retirement is kind of like an amortization problem, which again, very appropriate with the amortization, like death, very mortality, right? However, before that, what you're saving up, this point, you know, I want to retire in a certain way. So now you have to choose what payments do I need to save up to that FV. So from this perspective, when you're young, this is a future value, right? But it's actually equivalent to the present value of the old you, right? So there's going to be you at 60, and that's the money he's going to have in the present, but that's not money you have now. This is money that you're going to have in the future. So when you're young, you're taking the future perspective. When you're old and in retirement, you're taking the present perspective, right? And so that leg of your journey is a sinking fund leg. Right? How much money do I need in retirement? That's an amortization formula. Okay, how do I get that amount of money? That's a sinking fund formula, right? This is how you use the problems, and you mix and match. So you just have to know, what do I need to accomplish? What is the goal that I'm looking for? Am I saving up to something, or am I paying down something, right? And then based on which one it is, you use the right formula. We're going to end it right there. So I wanted to do some more examples, but I don't want to rush through them. So what I'll do is I will leave them here for you to try, which is probably a good exercise anyway, because really, I was just going to have you guys watch me work these out without actually teaching you anything, because I actually expect you to know this already. So understanding systems of equations is going to be very important for chapter 5. You know, that's when you have systems of linear equations specifically. So I want to make sure that you can set them up. And then once you've set them up, you can solve them. So here's a problem where it's a word problem, and you're pretty much going to set up some equations. And here's another one, right? So you're going to be setting up equations that look like, you know, ax plus by equals c, dx plus ey equals f, right? Like a system of equations. Like by the time you finish this problem, you're going to get this system that you have to solve for x and y. This one is going to have 4 variables, but it's the same idea. And this one is going to take, I believe it was 2 equations, 2 linear equations of 4 variables. And this one is going to have you set up 2 linear equations of 2 variables, right? But again, this is something that it's like an algebra or pre-calc topic. It's not officially something that's in our syllabus. And I don't want to actually waste time teaching you, but you need to remember this. So you need to remember first of all, can you read those sentences and come up with the equation? Second of all, once you come up with the equation, can you solve it? Do you remember the substitution method or the elimination method or something like that, right? So spend this weekend, jog your memory about that. At this point, you can finish all the homework for chapter 3 in theory. But yeah, we'll end right there. Try these for next class. We'll quickly go over those and then we'll start chapter 5, where we're actually going to make the linear equation scenario more complicated because instead of equalities, we're going to have inequalities and it's going to be fun. Okay, so you need to learn how to deal with the equalities first. But yeah, we're going to wrap up there unless there are any questions. Okay, I think we're good. Yeah, we'll stop right there. Thank you for your attention. Have a good weekend, and I'll see you guys in the next